So moving on to instruction sets, we're going to learn a little more about that. So a computer should have a set of instructions such that the user can construct programs to evaluate any function that is known to be complete. As in, like I said, every system has its own set of allowed micro operations, right? Depending on the hardware, the architecture used. So an operation which is supported by system A may not be supported by system B. Each has its own set. Now, irrespective of what system I am using, what hardware that system has, what set of operations are allowed and what are not allowed, my system should be able to execute the program I write. So you should not have constraints like this program can only be executed on this system, this program can only be executed on that system because this system does not allow this particular micro operation, only that system allows a certain micro operation. That kind of restriction should not be there. Of course, there are restrictions in terms of like a task which a supercomputer performs cannot be performed by a mobile phone or a laptop. That is there, but that is mostly in terms of scale, in terms of complexity, in terms of time and resources. It's not in terms of the instructions which are legal and illegal for a specific system. So in terms of the allowed set of operations, every system should be able to execute every program I write. So you can give it different names. For example, the system A, the read operation may be called read. In a system B, it may be called the fetch operation. But ultimately, if I give a program if I write a program which asks the computer to read a certain file, both should be able to read. That is what we mean by instruction set completeness. A set of instructions is said to be complete if it can perform machine language programs to evaluate any function. So within instructions you have different types. Functional instructions are those that perform any function like arithmetic operation, logical operation, shift operation, relational operation and so on. Transfer instructions transfer data between the registers and the main memory. Control instructions are responsible for the program sequencing and control. So they decide which instruction has to be executed first, in what sequence the instructions are executed, when there is an iterative code, when there is a loop or something like that, which statements have to be repeated, how many times, when do you stop the repetition and come out of the loop, or if there is a conditional statement, how the control flow jumps. Once a specific condition is met, you do not look at the remaining else statements, you come out of the conditional and you look at the next statement. So that flow of control is decided by control instructions. And then input-output instructions are used for receiving input or displaying the output. So these are the different types of instructions broadly which make up any set of micro operations.